Good morning, students. Once again, I welcome you to my channel. In the last class, I explained about the test signals that are used in time domain analysis of control system. The three test signals are step signal, then ramp signal, and then parabolic signal. You can also include impulse signal. Now, to continue further in this chapter, now time response of first order system. As you know that control systems are classified on different bases. One such basis is order. Order, what is order of a control system? The highest power of S in the denominator of transfer function is what is called as order of the system. Now, first order, second order. In a control system, we restrict our study to only first order system and second order system. First order system is going to lay down the foundation for second order system. Higher order systems are approximated to second order. So, time response of first order system. So, how first order systems behaves when subjected to different inputs in time domain. Now, as you know that we have to consider three types of inputs. Now I will consider first step signal. So time response of first order system due to step input. I will consider first step input and I will consider unit step input. Okay. Time response of first order system due to step input. It is what is called as step response of first order system. Now we shall go through first order system. Now before proceeding further, you are supposed to know represent first order system. So first order system is represented by this transfer function. Cs by Rs equals 1 over tau s plus 1. This is what is called as first order system. This is the general representation. Cs by Rs equals 1 over tau s plus 1. So tau is a constant. Tau is a constant. Tau is a constant. You have to very well remember this formula. Some of you may question, how came this expression 1 over tau s plus 1? I will give an example. I will give an example of electrical system, that is RL circuit. I will give the example of RL circuit. Now, I will give the example of RL circuit. Now, this is input and current is output. VT is input, IT is output. VT is input and IT is output. Now this is a first order system. Now first order system will have one energy storage element. So as you know that resistor cannot store energy. It can only dissipate power. Whereas inductor can store energy. Therefore the order of the system depends on energy storage elements. So one energy element means first order system. Now if you write KVL equation for this, V of t equals L di by dt plus IR based on Kirchhoff's voltage law. If you take Laplace transform for this, neglecting initial conditions, we get V of S equals Ls Is plus R into Is. Then if you simplify this, we get Is by Vs equals Is by Vs equals 1 over Ls plus R. Is by Vs equals 1 over Ls plus R. And if you take out R as common factor, 1 over L by R S plus 1 plus 1 into 1 by r. 1 by r. Now L by r is what is called as constant. L by r is a constant. You can call this as time constant tau. So if L by r is a constant, then this expression is r into tau s plus. You can forget about this r. Okay. Now what is the general expression? The general expression is 1 over tau s plus 1. I hope students have followed this. Now take step input. Input is step input. R of t is a step input. R of t is a unit step input. This is R of t. What is Laplace transform of this? R of s equals 1 by s. R of s equals 1 by s. Then substitute here. C of s over 1 by s is equal to 1 over tau s plus 1. If you simplify, C of s equals 1 over s into tau s plus 1. Now I am not explaining the partial fraction expansion. Now resolve this into partial fractions, that is a by s plus b by tau s plus 1. So student can go through partial fraction expansion. Now C of s equals 1 by s, a by s plus b by tau s plus 1. Now if you expand and using partial fraction, then a comes out to be 1 and b comes out to be minus tau. A comes out to be 1, b comes out to be minus tau. Therefore, C of s equals 1 by s plus minus tau by tau s plus 1. Then 1 by s minus, take tau outside, we get s plus 1 by tau. Tau get cancelled, equals 1 by s minus 1 by s plus 1 by tau. 1 by tau. Now if you take inverse Laplace transform, for this, you know from inverse Laplace transform, L inverse of 1 over s plus a is equal to L inverse of 1 over s plus a is equal to L inverse of e to the power of minus 80. E to the power of minus 80. Now here we get C of t equals 1 by s. L inverse of 1 by s is 1. L inverse of 1 by s plus L inverse of 1 over s plus 1 by tau equals L inverse of 1 by s is 1 minus 1 minus, so here it is minus then 1 over s plus 1 by tau, that is e to the power of minus t by tau. So this is what is called as time domain expression of step response. Step 1 minus e to the power of minus t by tau. So it is an exponential function. You can sketch this. You can sketch this graph. If you sketch this graph, we get C of t. See, at t equals 0, C of 0 is, substitute t equal to 0, we get 1 minus 1, that is 0. That means it starts from 0. And at t equal to infinity, C of infinity becomes equal to 1 minus 1 by infinity, that is 1 minus 0, that is 1. So C of 0, 0, C of infinity 1. If you sketch the graph, it is like this. So at t equals infinity, it becomes equal to 1. Therefore, this is the graph. This is graph C of t is equal to 1 minus e power minus t by 2. And now you can plot the graph for different values of tau. So you change the values of L and R. So if you increase the value of tau, now the graph will occupy position below this. As you increase the time constant, the system takes more time to settle at a value 1. So it exhibits what is known as sluggish behavior, late response. It takes more and more time to reach this value. Therefore, if you take tau to be too large, then it takes more time to settle. So this is what is called as step response of first order system subjected to step input. So this is C of t. One has to remember this. In the next class, I will consider the another type of input, what is known as ramp input. Thank you.